So our next speaker has no less experience working for the Fed and the ECB. Educated in Princeton and Harvard, he has worked for 5 of the 12 U.S. Federal Reserve banks, consulted with the ECB, and cooperated with several other renowned international institutions. He's an associate professor at the Brandeis University, a research fellow at the CBR, vice president and scientific director of CBRA, and research consultant of VRB Cleveland. The main research interest of our next distinguished guest are implications of price setting for macroeconomic modeling and policy. His recent work expands on the interaction of price setting with the network structure of the economy and inflation expectations. He also explores the role of beliefs in households' financial decisions. Most of his research deals with price setting features, specifically price rigidities, the critical element in our monetary models. For example, in one of his papers, he shows that one can break monetary policy neutrality by assuming rational inattention. Hence, he explains why monetary policy has real effect and in what instances monetary policy can impact variables like GDP or unemployment. His academic work is often, one could say, provocative and intriguing. In today's contribution, he will share his latest empirical findings about the inflation expectations. When we think about the audience of central bank communication, we do understand that there are differences between the nature of expectations among professionals and households. But as always, Raphael goes beyond this and tests the nature of our inflation expectations. If we stretch his findings a little, we can say that he will attempt to convince us that 1 + 1 = 3. But let's stop being cryptic here and let me invite Mr. Raphael Schoenle and give him the floor, please.
Well, thank you very much for the kind introduction, and thank you very much for putting the paper on the program. So I will be presenting Greater Than the Sum of Its Parts, Aggregate versus Aggregated Inflation Expectations, which is joint work with Alex Dietrich at Notec, Christian Merced, Rob Rich, and Michael Weber, and 2 of my co-authors here in the floor. Let me also state that the usual Fed disclaimer applies. And let me start by showing you 2 cartoons to summarize the motivation behind our paper. So first, this is how central bankers, statistical agencies, macroeconomists think about inflation. So in pi, inflation is an aggregate object, and it's defined by the rate of change in the price index, such as the CPI, the consumer price index, between 2 periods. And the price index itself is the sum of individual prices PTI that are subject to some elasticity of substitution. And if you ever looked at the manuals of a statistical agency, you know that these equations can get massively more complicated. To make matters even more complicated, you might want to throw some statistical tools like factor models or computation of robust measures of inflation at this to get at an underlying gauge of inflation. This is how consumers think about inflation. So when consumers think about inflation, they tend to think about prices of very few goods, such as gas or prices of a few specific food items. So when we think about inflation expectations, then perhaps we have to ask ourselves, are our measurement practices of the beliefs of future inflation expectations adequately calibrated with actual consumers in mind? So what we do in this paper is to take off our hats as macroeconomists and policymakers. So that's the first cartoon. and instead rethink measurement of inflation expectations with the actual consumer in mind. So that's the second cartoon. And this leads us to the creation of a novel data set that contains both microtype and macrotype inflation expectations. That is, category inflation expectations for all the major personal consumption expenditure categories, as well as conventional aggregate inflation expectations, along which we also measure spending expectations. And then we ask, how do category inflation expectations relate to aggregate inflation expectations as well as consumption spending plans? Based on these two exercises, we find that category inflation expectations contain additional information about consumption spending plans that are not contained in conventional aggregate inflation expectations. Aggregated category inflation expectations are also consistently informative, while conventional aggregate inflation expectations are not. Generally, aggregate inflation expectations tend to exceed category inflation expectations and are more volatile, and their internal aggregation mechanism is related to sociodemographics, task complexity, and the use of heuristics. So why do we care about this? So there are several reasons why we might care about this. One is obviously the implications for the measurement of expectations. So our results suggest that rather than measuring abstract aggregate inflation expectations, we might want to focus on measuring disaggregated category inflation expectations. So this approach is based on the insight that aggregate expectations concern abstract, uncertain variables, which humans predict using heuristics, but that are subject to well-known biases. By contrast, category expectations concern tangible, better understood variables, which might be less prone to the use of heuristics and subject to an easier recall of relevant experiences when we form our probability assessments. So these considerations basically call to arms for forming a theory and developing a theory of optimal expectations measurement. And second, we might care obviously because of the implications for policy. Our category expectations data imply an estimate of the intertemporal elasticity of substitution when we estimate an Euler equation that is different from the estimate that we get when we base this on aggregate conventional inflation expectations. Obviously, this is a key parameter for the effectiveness of monetary and fiscal policy. Our category-based estimates imply, for example, that monetary policy may underpredict inflation volatility in a very simple New Keynesian textbook model relative to using an aggregate-based estimate. And finally, our findings present complementary novel evidence that does not support the rationality of aggregate inflation expectations. So in an influential paper, Kwabion and Gronichenko reject the full information rational expectations paradigm fire by comparing inflation expectations to inflation realizations and showing that forecast errors tend to be autocorrelated. So our analysis in this paper reveals an inconsistency in the rationality of inflation expectations by showing that there's an inconsistency of aggregate inflation expectations and category inflation expectations when we aggregate them up under plausibly rational aggregation schemes. So this is maybe the 1 + 1 is 3. And then second, we point out that aggregated category and aggregate inflation expectations do contain differential information. So let me get right into this. The data we use is based on the Federal Reserve Bank of Cleveland's daily survey of consumers, which I started when I was at the Federal Reserve Bank of Cleveland. The survey includes a module on category inflation expectations, and the data that we use for this paper is between July 9th, 2020 and August 9th, 2022. But I should say the survey is ongoing every day, and the survey also contains aggregate inflation expectations since March 2020. The survey is representative of US consumers according to age, gender, race, income, education, and region, with about 60,000 observations. And we use survey weights to adjust for any sampling inaccuracy. So what do we measure precisely? So first, we measure conventional aggregate inflation expectations over the next 12 months using both the point and the density forecast following the New York Fed SCE. And this is the question we ask respondents. Over the next 12 months, do you think there will be inflation or deflation? And then depending on the answer, respondents can get asked, what do you expect the rate of inflation or deflation to be over the next 12 months? And then they fill in their best estimate. Second, we elicit category disaggregated inflation expectations over the next 12 months for 11 personal consumption expenditure categories that cover the entire PCE basket, and we subsume some minor categories to limit the cognitive burden. So these are the 11 categories. They include, for example, food and beverages, housing and utilities, gas and other energies, and several more. And in our survey, we show examples to illustrate to respondents most product categories, such as motor vehicles and parts, such as cars and services, just to make sure they understand. We also elicit consumption spending plans over the next 12 months, both for total spending, services, and non-durables. Asking respondents, compared with your spending last month, how do you expect your total spending to change? And then in the next 1 to 12 months or 24 months, and respondents can choose quite analogously to the other question to go up, no change, go down, and then fill in the best estimate. And then finally, we also elicit category weights by dollar spending or importance of categories. Let me show you the text for the first. So here we ask respondents in terms of consumption spending, how much money did you spend in each of the following broad consumption categories during last month? And then it can indicate again the number over the 11 categories, which we can then normalize to get a spending weight. And of course, let me show you our main category inflation expectations questions. So here we asked 12 months from now, what do you think will have happened to the price of the following items? And then an analogy to the main question, for these 11 categories, consumers can choose increase, decrease, and then fill in the amount. So let me show you what these statistical properties are for aggregate and category inflation expectations. And our general finding is when we compare aggregate and category inflation expectations, that the aggregate inflation expectations exceed category expectations along several dimensions. We find that there's a higher aggregate mean than for any category. Aggregate dispersion tends to be higher than dispersion for any category, and the aggregate time series volatility is higher than for any category. On top of that, there's an important insight from our individual level data, which is that 40% of individual aggregate expectations lie outside the range of the individual category expectations. So 25% of respondents report above this range by about 7 percentage points, and 15% response about below by 12 percentage points. So this really makes clear that linear aggregation of expectations from the category level is not possible. And let me show you some numbers in 3 or 4 slides. So here I'm showing you the mean, the cross-sectional dispersion, and the time series standard deviation of the cross-sectional means for the aggregate and the category expectations. And you can see that the aggregate mean tends to be higher than any of the category means, and the aggregate expectations also tend to be more dispersed than any of the categories. And perhaps healthcare has the lowest expectations. So let me also show you here the time series for the aggregate expectations and the category expectations. So on the left, I'm showing you durable and non-durable goods. On the right, I'm showing you services. And the black line is the same in both figures. That's the aggregate inflation expectations. So both figures show you time series for the 11-day moving average, Huber robust survey-weighted mean. And you can see that reported aggregate expectations tend to be higher than the individual category expectations, while also service price inflation expectations were somewhat sticky in 2022. Now let me dig a little bit deeper and show you category and aggregate means by demographics, in particular gender, whether the household is the respondent is the household grocery shopper, by education and income. And you can see that there are much wider gaps by demographics at the aggregate level. So take the 7.3 and 6 versus any of the category gaps, but it's generally true. And then trends differ also by education and income. For example, low educated respondents tend to have higher inflation expectations, but that's not true across the categories. And so this points to generally the complexity perhaps of these aggregate macro concepts. And then the salience of shopping experiences doesn't have an inconsistent relationship across aggregate and categories. And if you also look at the dispersion, there you see very briefly across these demographic groups, no real difference across in the trends, although again the gap is wider at the aggregate than at the category level. Really interesting demographic is age. So if you look if you compare aggregate and category expectations, the trends somewhat differ. There's maybe a nonlinear pattern at the aggregate, but there's a very clear pattern with increasing inflation expectations across categories. And for dispersion, you don't really see much of a difference. Now, that I've sort of described this in great detail, let me tell you how we aggregate these categories and then compare aggregate versus aggregated inflation expectations. And they're going to see that aggregate category-based inflation expectations tend to be closer to zero than the conventional measures, while they're also less dispersed. And then a positive aggregation gap, or plausibly an inconsistency for rational aggregations arises, which points to internally inconsistent beliefs, while we tend to find that equal weighted aggregation provides the statistical best fit, which all cast doubt on the rationality of aggregate inflation expectations. And then this gap varies with uncertainty and socio-demographic factors. So how do we aggregate these category beliefs? Well, we use different sets of weights, constructing 8 measures of aggregated inflation expectations for each respondent based on their inflation expectations by category and appropriately weighting them. And we use 2 sets of weights, plausibly rational aggregations, which include their reported expenditure weights, the importance weights, and then the official PCE weights, which should count as a rational benchmark. We also use behavioral aggregations, where we use equal weights, which neglects any differences in weights. Excuse me. And we use order statistics, recording the first and second max, which emphasizes the importance of salience price changes, as well as core and non-core aggregations, which emphasize particular salient price changes, such as gas, energy, and grocery prices. So here I'm showing you a comparison of aggregate and aggregated measures of inflation expectations in the cross-section. The left panel is showing plausibly rational aggregators, the right behavioral aggregators. On the y-axis you have the conventional aggregate expectations. And you see very clearly there's a positive aggregation inconsistency for plausibly rational aggregations, in that aggregate expectations tend to exceed these aggregated expectations, but they move one-to-one in much of the range, but are possibly nonlinear at the extremes. And then statistically, an equal weights aggregator fits best in the cross-section. Here I'm looking at means in the time series, again for the 2 sets of aggregators. And again, you see there's a positive aggregation inconsistency relative to the black line, which represents the conventional aggregate measure of inflation expectations. In particular, these expectations exceed any plausibly rational aggregations, and the volatility, which is particularly pronounced in the recent high inflation period. And then statistically, again, an equal weighted aggregator fits best also in the time series. I'm going to skip the dispersion here for the sake of time. Now the question is, what are driving processes of the aggregation gap? So to answer the question, we rely on our individual level data, and we compute this lambda, which is the difference between aggregate inflation expectations and aggregated inflation expectations. On average, lambda tends to be between 0.68 percentage points and 1.64. We obviously exclude the order statistics, which make this very negative. And the magnitude is large of lambda. It's between 5 and about 9 percentage points. To understand this better, I'm going to take the lambda and regress this on a rich set of covariates, which we get from the survey, including sociodemographic factors and measures of complexity. So this table shows you results for the case of an aggregator with expenditure weights. These results generalize, so I'm really just sticking to one example here. And you know, I regress here the absolute aggregation gap on a really large set of covariates, and I'm just highlighting 4 in blue in the second column. And basically two main findings emerge here. Aggregation, so excuse me, education and the age gap, and age decrease this gap, which is pointing to the potential role of mental abilities and perhaps wisdom of age, while at the same time, aggregate inflation expectations uncertainty, which we can measure at the individual level through the density forecast, and the dispersion across categories, also measured at the individual level, tend to increase the gap. These are the last two variables here, which points to the degree of complexity embodied in these variables. Here I'm showing you graphically, especially what these two variables look like. On the left, on the y-axis in both panels, you have the absolute aggregation gap, like in the regression. On the x-axis in the left panel, you have the forecast densities, the density forecast, individual level dispersion summed up into 11 bins. And on the right, you have the standard deviation of the category inflation expectations, also binned into 15 different bins. And you see basically that across all these aggregators, the gap rises linearly with the measures of individual aggregate uncertainty and dispersion, rather than, you know, perhaps having a flat relationship as you might have expected. So the question is, of course, you know, why do we care? Besides thinking about implications for measurement and the rationality of aggregate inflation expectations as we measure it. Obviously, our results might be important for implications in terms of modeling and policy. And we show this by estimating an Euler equation based on category-based expectations, finding that we get a better fit of spending forecasts. We find different estimates of the intertemporal elasticity of substitution. And then, crucially also, this analysis reveals a key relative informational advantage of aggregated inflation expectations. And I apologize for the typo. And our estimates imply potentially a reassessment for the stabilizing role of monetary and fiscal policy. So to show that our category-based expectations contain additional information, we basically run a horse race. And we ask which measure of inflation expectations predicts spending plans best. Is it conventional aggregate inflation expectations, or is it aggregated inflation expectations? Of course, we need to use additional survey data on expected changes in spending, which we have. And then we can estimate an Euler equation where we vary the measure of inflation expectations on the right-hand side. And because consumption spending plans depend on, in real terms, depend on inflation and nominal spending plans, we can directly read off from this estimation the intertemporal elasticity of substitution by looking at our estimate of beta 1 hat. And our specification also controls for household income expectations, various social demographic factors, and time fixed effects. And we measure the goodness of fit by, again, applying the archaic information criterion. So this table shows you what we find, namely that category-based expectations contain additional information and provide different estimates. So here, in the first row, you see our estimate when we use conventional aggregate inflation expectations. So then the intertemporal elasticity is 0.96 with some associated archaic criterion. And by contrast, you see that all of the category-based estimates are lower. And by looking at the last column, you can also see that they predict spending better. And it turns out, if you want to pick a particular favorite, that statistically the equal weighted aggregation predicts the data best with the lowest Aggregate criterion. And we can repeat this with similar results when we look at outcomes for consumption, service spending plans, and non-durable spending plans, as well as applying an instrumental variables regression where we use the forecast density mean. You might want to ask, which of these category-based aggregate expectations is better in relative terms. So this is what this table shows you. So here, if you look at a row, we're considering the likelihood ratio of a row specification versus a column specification with a different measure of inflation expectations. And you can see very clearly that equal weights outperforms all other measures of aggregated expectations. But you also see very clearly from the last row that conventional aggregate expectations are outperformed by all of these measures of aggregated inflation expectations. So this is my 2 more slides, I believe. And so estimating Euler equations also reveals a key informational advantage of using aggregated inflation expectations. And this is what this figure shows you. So let me walk you through here. This figure shows you a comparison of explanatory power when we estimate an Euler equation with inflation expectations on the right-hand side relative to one without inflation expectations. So this figure plots this improvement in R square of adding in inflation expectations by, this is on the x-axis, the aggregation gap, the lambda I that I showed you earlier, which we know relates to socioeconomic demographics and complexity. And there are 2 lines here to pay attention to. So the black line uses the conventional inflation expectations on the right-hand side, while the red dashed line uses aggregated inflation expectations when we use expenditure weights. And you see a key result here, which is that aggregated inflation expectations consistently turn out to be informative even as this gap increases, for the aggregation gap. While if you look at the black line, it's based on the conventional estimate, this additional information essentially goes to 0 as this gap increases. So this really suggests that aggregated inflation expectations may present a superior measure given the sociodemographic heterogeneity and the uncertainty that's embodied in this aggregation gap, which is key if you would like to get at the effective belief that people hold in terms of inflation. And then finally, it may be obvious, but the intertemporal elasticity is also a key parameter in our models, which suggests that our estimates may imply a reassessment of monetary policy. In particular, potentially large welfare relevant effects may arise if we plug in these different parameters into a standard textbook Keynesian model a la Galli and simulate it. So this table shows you 2 welfare relevant metrics, the variance of inflation and the variance of the output gap. In the first row, we use an intertemporal elasticity of 0.863. Then we use an equal weights-based measure, and then one based on a recent paper from the New York Fed. And you can see this has an impact on inflation volatility as well as the output gap. And obviously, this key elasticity also may impact other aspects of policy, such as forward guidance. What I've shown you here is a novel survey of category microtype inflation expectations, and I've shown you that aggregate and aggregated inflation expectations exhibit different statistical properties. In particular, there's a significant gap, if not an inconsistency, between the aggregate and aggregated inflation expectations that tends to be more pronounced for individuals with low socioeconomic status and increases with complexity of tasks. And I've shown you estimates from estimating an Euler equation that indicate that category-based expectations contain additional information at the aggregate, and they do so consistently across different groups of the population. And potentially these estimates also have large implications for policy. like overall, I see this analysis really only as a first step. There are many open questions. What is perhaps the optimal level of this aggregation to elicit effective inflation expectations might be one. Thank you very much.
Many thanks to Professor Schoenle for his lecture. And now I would like to introduce you our next speaker, Professor Hajime Tomura from Waseda University as our discussant. Professor Tomura is focusing on the financial systems, payment systems, and financial crisis. So you're quite busy with your portfolio. And now, the discussion floor is yours, please.
Thank you, Chair. So my name is Hajime Tomura from Waseda University in Japan. Thank you for the opportunity to discuss this great paper. So this paper reports a very interesting survey result that the average expectation about the aggregate inflation rate was higher than the expected inflation rate of any subcategory of goods and services. As a result, the average expectation about aggregated inflation was also higher than inflation expectation measures produced by aggregating categorical inflation expectations. Regarding the reason for the gap between aggregate and categorical inflation expectations, the authors find that this gap was more significant for survey respondents reporting higher degrees of subjective uncertainty about their expected inflation. And given this result, the authors highlight cognitive distortion for the explanation of this gap. For the sake of discussion today, let me pose 3 questions about this paper with some personal comments. The first question is why the average aggregate inflation expectations consistently exceeded aggregated measures of categorical inflation expectations. So this finding is demonstrated in figure 3 of the paper. So the black line is the aggregate inflation expectations, and the other lines are aggregated categorical inflation expectations. As you can see, for the entire sample period, it has been the case that the aggregate inflation expectations was at the top. So the question is why this is the case. So if cognitive distortion is a reason for the gap between aggregate and categorical inflation expectations, then it could be the case that cognitive distortion only produced symmetrically distributed noises with zero mean in the survey, but it was not the case. So there may be something structural behind this result. And when I read the paper, I find that the actually authors give alternative interpretation of, let me switch, alternative interpretation of their findings on page 10. So let me just read the paragraph. A potential explanation for the gap might be that respondents interpret the aggregate inflation question as referring to a macroeconomic variable, while they understand the category-specific question as referring to subjective inflation rates based on the goods and services that they personally consume. To my reading, the authors sounded in the paper, at least, somewhat dismissive about this alternative interpretation, but I think this interpretation may still help to understand the author's finding if they are combined with the effects of product turnovers. So as we all know, firms occasionally introduce new products, and there are papers reporting the fact that retail prices tend to decline as each product ages. And for Japanese case, Professor Watanume's paper find this fact. So this is just a simple characterization of what I say. So today there's some incumbent brand, and tomorrow a firm may produce some new brand. And the incumbent brand tend to have a price decline, and new brands start with some high price. So if I apply, or if I combine the author's alternative interpretation with the effect of product turnover, I may be able to say that for the category-specific inflation questions, survey respondents answered their expected price changes regarding incumbent products. So they answer somewhat lower inflation expectation number. But then, given that, or if the survey respondents interpreted aggregate inflation question as about macro variable like CPI or PCE, then from the macro statistics, they may answer their expectations about the overall changes in the price level. That would include the prices of new products. So I think the author's alternative interpretations may help for this reason, because the effect of product turnovers, the fact that new products tend to be priced higher than incumbent brands, or the retail prices tend to decline over the cycle of each product. Based on this fact, maybe it's natural to observe that aggregate inflation expectations reported by survey respondents were higher than the categorical inflation expectations. And I find that actually there's some supporting evidence presented in the paper in line with this interpretation. So the corollary of this conjecture is that if the prices of new products are expected to be priced higher, then aggregate inflation expectations and aggregation gaps between aggregate inflation expectations and categorical inflation expectations will be higher as well. And that's the case in the table 22 reported in the paper. So the authors compared their result in a low inflationary environment and high inflationary environment, and in fact the aggregation gap becomes higher in a higher inflation, more inflationary environment. But this is certainly a theoretical conjecture. I mean, this got to be confirmed empirically, which is not done. I don't have ability to do it, but so I'm still interested in further discussions about this interesting fact by the authors. So that's the first question. And the second question is cognitive distortion the only major cause of the aggregation gaps? So the authors ran a demographic regression, and the authors found that in fact, education matters for the size of aggregation gaps. So less educated tend to answer higher aggregation gaps. So that's very supportive. But if we look at the demographic regression, there are other factors that have significant coefficients. So my question is, what's the author's view on the relative importance of different factors? There still may be some evidence to say that actually cognitive distortion is still the most important cause of aggregation gaps, but that's my question. And let me just extend, for the purpose of discussion, let me just extend how we can interpret the effect of age effect. So there, the demographic regression shows that, in fact, as survey respondents were older, then they tended to answer less aggregation gaps. And why is so? So, to my impression, on top of cognitive distortion, in addition to cognitive distortion, there may be some role played by rational inattention too. So my reasoning is the following. So younger people tend to live on tighter budgets than older people due to an imbalance between their spending needs and income. And these comments coming from my personal experience. I did my PhD in London, UK. At that time, the city was very expensive, and I lived on a very tight budget. So So this is generalization of my personal experience. So given this, tight, the presence of tight budget, younger people may pay more attention to the prices of their daily purchases. In contrast, older people have accumulated income over time, so they are more likely to have financial investments. And I'm like them too. So those people may pay more attention to financial market indicators, including CPI, PCE, inflation rates. So it may be the case that older people may not know much about the price or do not pay attention to prices of their daily purchases, but they know more about macro variables. So they may form some their conjectures about category-specific inflation expectations from their macro expectations. So that's just my personal thought. Okay, and I have only 5 minutes, so let me move on. So the last question is on a larger issue regarding the role of expectations in monetary policy making. So the authors mentioned the general equilibrium implication of their finding. Their estimates indicate the estimate of the intertemporal elasticity of substitution would be lower, and that have important implication for the simulation of general equilibrium model. That's important, but given the importance of their findings of household expectations at micro level, what I thought was the paper may have more far-reaching implications than those discussed in the paper. More specifically, expectations are often assumed to anchor steady-state inflation in new Keynesian models. And to my impression, this is interpreted as the role of inflation targeting by the central bank through rational expectations. Then, if household expectations are subject to cognitive distortion, then they may not anchor the long-run inflation rate, because cognitive distortion kind of deviates from rational expectations. So my question is, should the central bank still pay attention to expectations? If so, how? Coincidentally, this question is similar to what Meredith asked in session 1 in the morning, but I'm still curious about author's view and further discussion in the context of this paper. So this is a summary of my questions. Thank you again for the opportunity to discuss this path-breaking paper. Thank you.
Many thanks to the discussant, and now I'm Professor Schoenle. And finally, I would like to introduce you also the co-author of this paper, Professor Marset from University of York. So, would you like to respond to the questions of discussion?
Yes, of course. So first, thank you very much for the excellent discussion. So please share the slide with me. I think, I'm very sympathetic to all of your comments, obviously. Like I tried to say, I think there are many questions here, and it's worth thinking about all of them. And ultimately, a lot of them need an empirical answer, right? So we need to do more measurement to get something to guide our theoretical efforts here. I think this is really a call to arms. I think stepping back from this for a second, I think what we try to argue at a more abstract level is, there is some information in asking people about these more disaggregated categories. And if we care about the Euler equation, for example, then this shines through. I think that's sort of the key insight. And then obviously we'd like to figure out, which we talked about here, like where this is coming from, and you offered some suggestions, so which we be happy to investigate more in further work. So I think product substitution could be an interesting avenue to pursue. And then your question obviously is also about the type of cognitive distortions. I highlighted 4. I think the same applies to sort of all of these behavioral models, and we haven't really figured out what are sort of the main theories here, and what are the main factors that drive that are really behind these behavioral stories beyond this particular example. So for the question about age, for example, you know, the different ideas I just loosely think that there might be actually something, like you said, there's some kind of wisdom of age, and it could be connected to the experience you point to in your comment about rational inattention, right? And other circumstances can make people learn over the life cycle. So you update your models, but all of this is very contingent on like the environment we live in. This could be invalid in a completely different regime. I think that rational inattention, I think, is definitely a theory. I don't know which is the right behavioral model. I think we are really trying to figure this out. And against that, I think stands just this potential that there's something more tangible to people by thinking about things they observe, and potentially this can be modeled as rational inattention. But I wouldn't recommend restricting our modeling approaches here. I think we need to explore a lot more what people do. So your first comment, for example, would go in that direction. I don't know, Christian, if you want to add anything.
Thank you very much. Perhaps just adding that one of the things we're trying to do here is to explore ways of asking about inflation that may be more meaningful to the consumers and to the respondents. And I think a big picture of our results is that we seem to find evidence that asking about the more concrete, tangible categories seems to give answers that are providing more information when we relate it to their spending plans. And I'd also like to echo what Raphael was saying about the mechanisms behind this. This is, I think, a really big, interesting question, and we need to look more into it. We were probably a little bit biased ourselves by a sort of salience hypothesis to explain why the aggregate inflation expectations were so high, but that doesn't really explain why it's higher than every specific category. But it may relate to the fact that many respondents don't really understand what inflation actually is, and for some reason are giving us an answer that isn't all that meaningful. Thank you.
So, okay, so thank you very much. And before the questions from audience, I just two quick questions. And so, should I understand that your simple recommendation is to revise what are we asking in households in surveys? That's precisely what you said. And the second one is, how do you see the applicability of your aggregation principle in other than PCE index? Perhaps in HICP. So would you see any difficulties rising from different structure?
I think these are very good questions. I think we haven't tried this with different aggregation schemes. My guess is if it's true there's a behavioral pattern at work, it will shine through any aggregation from different categories. So HICP could be one. We also ask this comparison and some robustness checks. The outcome specifically is CPI, it's specifically PCE. So none of this really matters. People could think about different aggregators. I don't think they do, but they might. And it might carry over to many other domains, right? Like in GDP measurement and so on, which are similarly structurally. I think it ultimately needs more measurement. And I think we only present one example here. I think the time series also needs to develop a little bit. We have about 2 years, and following up this maps into PCE categories. So we will see actual consumption decisions. So if we have a long enough time series, we can get a lot out of the heterogeneity and the actual decisions. So this might be another way to decide how informative this is. So, and for now, I would just say it's probably worth exploring where this extra information is coming from, and just measure things as a starting point, because we don't have these measurements yet.
Okay, so any questions from audience, please? Professor William, please.
Just have a clarification question. So typically how you aggregate depends very much also on some preferences as well, like CES preferences. But is it correct that you're arguing for any preferences you can imagine, the aggregation would not be consistent what you're finding empirically? Is this, to understand this correctly?
Should I answer?
Because you mentioned it irrational, so you said there's no rational way to justify this. Yes,
no, that's a very good question. So, you know, to first order these, the regular aggregators tend to add up linearly. That's, you know, and that's how we see it to first order. But you can obviously take second order approximations. There should be like a bias term, which then would not be consistent with thinking about this aggregate response lying outside the range on both sides. So you have to have some other theory. What's going on in terms of the aggregators? There have to be some really interesting aggregator. We might be able to construct one. It's not a linear one. That's what we're saying.
But substitutability, that if you readjust across categories,
it's possible that you have some aggregator. We haven't even tried that. I think that's a very good suggestion. Yeah. Thank you.
Okay, the next question, please, Professor Brandeis, please.
Thank you. So it's very interesting to see this work on potential biases, and you're showing some avenue about how information can be improved. So the question I have is a question for your overall work, and it may actually relate to what we're going to hear tomorrow. Based on the research you've done, what advice would you give to central banks on how to communicate more effectively about actual past inflation to help the public understand what inflation has been, and to also guide the formation of expectations going forward? Again, it's all of this work collectively draw some conclusions. You are best placed to guide the rest of us who are not into this literature.
You know, my co-authors are sort of invited to chime in here. Especially Michael has done some work. So thanks for the question, Athanasios. I think how to communicate properly is very difficult. I think that's actually where some inattention story might come in ultimately, because you want to do something optimal as a policymaker and you want to distort people's attention, particularly in a bigger picture. Maybe it's people are doing something optimal. What our work might be suggesting is that people do focus on very specific categories when they form expectations. And if I think we have a long enough time series of this, we can repeat some of these exercises where we have realized inflation in different categories, forecasts, and then see how that relationship holds up actually at a very disaggregated level. It's definitely, it seems to be the case, people do understand these specific tangible things much better. So I think it's worth experimenting with their perception of communication when you do that, and you might talk about very specific product expectations and maybe make clear that, you know, that there's a focus that comes from a specific product, but that's not necessarily how we think about this. There are robust measures of inflation, for example, right? So maybe you need robust measures of expectations. I think there's a whole range of optimal communication and expectations measures you could develop based on these aggregated ones. But I would highly encourage to measure this more and then take it slow. Thank you very much.
Thank you. And finally, Professor Shuichi.
Okay, thank you very much. Here's my second age-related question. As much as I would like to believe that we get wiser as we age, my question is, does the cost of living adjustment of the social security system, will that be playing some role? Because they get this extra information through this automatic increase in their social security payments, especially older people. Thank you.
That's a very good question. Yeah, it's very hard to experiment with that. You know, to figure out what gives people creates the actual information. It's possible there's some information story that drives this. So I wish I had run an experiment where we had an answer for that, but it's obviously it's very difficult ethically to do that. So I don't feel comfortable jumping to some conclusion, but maybe Michael has a comment here too.
So I have an answer for you. So like we did that at some point last year, and everyone who receives Social Security claims to be aware that it adjusts with like cost of living, but they are not any better informed or better able to forecast inflation relative to younger participants. Like, you know, everyone says we do know that it adjusts, but when you actually look at the answers, they are not any better.
Thank you for help,
Thank
Professor Weber. And still, we have one more question from Professor Ichiue.
Thank you very much for the opportunity to ask a question, and thank you very much for the presentation. I really enjoyed your presentation. My question is about the distribution of responses. You seem to focus on mean and standard deviation, but I think it may be interesting to see closely the distribution. For example, it's well known that in Japan's survey, households tend to answer multiple of 5. For example, 0%, 5%, and 10%. So my question is, do you find any interesting pattern of answers in your survey and the difference between aggregate inflations and categorized inflation? Thank you.
Yeah, this is a very, very good question. I very vaguely recall we looked at this, but I don't remember precisely the findings. So I think this is worth exploring because we know that people have this discretized view of the world, and perhaps this is less the case with these very specific approaches than in the aggregate. So this could be another dimension that's worth exploring, potentially in connection with theories of rational inattention or other theories. So I think I have to look at the data, and then I owe you an answer there. Thank you.
So, thank you, dear professors, all in this row, for your findings. Really riveting findings, and also many thanks to audience for the patience and for time. Thank you very much.